Now, some time ago, I made a video review and I also demonstrated the Glastar Glass Scorer. Now, I believe Glastar is no longer making these. You might be able to find stock out there in the marketplace. Perhaps a store has some old stock or something like that. If you can't find stock of the Glastar one, then I believe that there is a generic brand out in the marketplace and you may want to consider purchasing that one. Now, if you haven't seen my previous video, I'll just quickly show you a clip from it so you can see how this works with this particular unit that I've made. So we put it on the edge there, push down, score, get our Lepinette running pliers, put it on the edge and break. And we'll do another couple. I find it really easy to use, I really do. Now, since shooting that video, I've had a lot of people ask me, how did I build the unit that I'm using the glass scorer on? Well, it's very easy to build, and it was actually built out of materials that I had laying around at home. Now, if you don't have any materials or any materials that are similar, you can always go to a recycle centre that recycles timber and see if they have something that you can purchase. Or you may have some people building a house around your neighbourhood that you can go in and ask them. They may have some offcuts and materials that you could use and build your own unit. Rather than go and buy new materials, because it's going to cost you more money and you're going to end up probably with more material than what you actually need to use for the unit. Now, the size of the unit is 440 millimeters wide by 600 millimeters deep. Now, you don't need that depth. I'm using this for scoring and breaking hobby sheets. Yes, I have larger sheets of glass, but the larger you go with this unit, the heavier it's going to become, and you've got to find more storage area to store it. So I find this size works well for me. Certainly the 440 works well. If you have a substrate that's 400 millimeters wide or 390 millimeters wide, if that works for your stained glass that you're going to be cutting or scoring and breaking, then that's fine, use that width. The 440 works well for me, and it just saved me ripping this sheet down, so I just went with that. 600 millimeters deep is not necessary. That's what I've got. It saved me ripping it down. But if you had one that's not as high, then that's fine as well, because I'm only using this for hobby squares. But just create the size that works well for you and the size glass that you're going to be scoring and breaking. This is 16 millimeter thick particle board. You might want to use marine ply. It's just what you have laying around at home, as long as it's got a smooth surface. Now, this has got a hard wearing melamine surface. If I didn't have this, I would be trying this out with marine ply. Anything that's going to be smooth, you want to use, because that allows you to slide the glass. But this works well. Now, this area up the top here is 440 millimeters wide. It's 40 millimeters high and 20 millimeters thick. Now, that height, that thickness is important, because when we put our glass scorer on there and we add a 3mm layer of stained glass or mirror, then that's about the right height that you're looking at here to correspond with the height of the glass and the glass scorer. So I find that 20 millimeter thick piece of timber here works well for me. What you don't want to do is go higher, where this is now higher and this is going to score on an angle. It's not going to be good for your glass, it's not going to be good for your glass scorer, and it's certainly not going to be good for you to handle that and trying to slide it across. So I find the 20 millimeter works really, really well for me in that thickness. Now, this is pine and it's smooth on top, and you want that because you want your glass scorer to slide across the surface effortlessly. The screws have been countersunk, again, because you don't want anything to obstruct that nice gliding across with the glass scorer. Now, when it comes to the sides of the screw, you're looking for a wood screw and one that can be countersunk. If you don't have any that can be countersunk, you can probably use another wood screw and countersink them anyway. But if you have one that's meant for countersinking, that would work really, really well. Now, the length of screw that you need is dependent on the thickness of the substrate that you go with. What you want to make sure that you do is choose a screw that's going to be long enough to go through the depth of this wood, but not too long where it's going to go through to the bottom of this substrate. You don't want it going through the bottom of the substrate. You want to make sure that the screw point stays within the substrate and not pierce through that bottom. And that is dependent, as I said, on what substrate, the thickness of substrate that you choose. And you also need to allow that you're going to be countersinking at 1 millimeter or 2 millimeters. If you find that you've got a screw that's slightly shorter than what you would like, you can always countersink this a bit further down anyway. This one's gone down about 3 to 5 mil. These here around about 2 millimeters. So just getting the right screw to work with this is dependent on what you have around at home. You might even have to buy a small packet of screws, but hopefully you'll have something that you can make do. Now when it came to putting the screws in, I just put a mark along the center, and then I divided the width of the actual pine into 5 areas to put the screws in. Now 5 is probably a bit many. You might want to put 3 or 4 in. But I'm not a professional, and so I just did it my way, and I prefer to over-engineer than under-engineer, but there's always more than one way to do a project anyway. Before I put the screws in, and let's assume this piece of wood, this pine wood, was not on here, I put a bead of glue down the center there, then I put the wood on, and then I can then adhere the screws into it, or I could leave it for 24 hours, come back and then put the screws in. It's personal preference. I like to put the screws in at the same time because it will push the wood down and wedge that glue in between the melamine and the actual pine here. Now I think the glue I used was a PVA, but I cannot remember. It might have even been Prep multi-use adhesive. I'm just not sure because it was done quite some time ago. So all I'm going to do is drill a pilot hole, and you can use a hammer and a nail to do this, but I'm just using this very small drill bit, and I'm just going to just start it. That's all I'm going to do. And then I'm going to take that out, put in a larger one, and I'm just going to put that in there and countersink it. There you go, that should be enough. Take that off, put in my fillet spit here, put the screw into that, and just drill and push down. Done. So that's all there is to it, and I did that 5 times or 4 more times across there, and then my unit was built. So it's very, very easy to make, and whenever you're using any power tools or anything like that, always follow the manufacturer's safety directions as well. Well, I hope this video has helped those people that have asked me how to build this unit to use with their Glastar glass scorer, and for those people that have one and have thought about building a unit, I hope this video helps you as well. Anyway, I hope you've taken something away from the video. If you have any comments, put them down in the bottom of the comments section of the YouTube channel, and also in the description box of this video are some other links I think you might be interested in, and I will see you in the next video. Enjoy.